In this video, we'll go over the basic steps for troubleshooting an arc fault trip by using the features and actions shown in the previous videos. For arc faults, focus on the RF arc noise meter in the dashboard tab, the RF arc noise waveform in the live data tab, and RF arc noise waveform in the record tab. First, verify the breaker tripped on an arc fault. Go to the load center and identify the breaker that is tripped. For Siemens branded AFCI and dual function breakers, reset the breaker and verify that a single LED turns on for a few seconds. This indicates the breaker tripped on an arc fault. For other brands, refer to the manufacturer's instructions to verify that the breaker tripped on arc fault. Step 2. Decide the IntelliArc installation type. If the circuit has a receptacle, install the IntelliArc in receptacle mode. The RF arc noise will appear in the circuit, so it does not matter which receptacle you plug into as long as it belongs to the circuit you're troubleshooting. If the circuit does not have a receptacle or it is inaccessible, install the IntelliArc at the load center using hardwire mode. Step 3. Take an ambient RF noise reading of the circuit. The purpose of this step is to set up a baseline to compare when turning on loads on the circuit you are troubleshooting. Turn off all the breakers in the load center except the one you are troubleshooting, and then turn off all the loads in the circuit. Connect to the IntelliArc with the mobile app, go to the Live Data tab, and observe the RF noise waveform. A relatively flat waveform is desired without any spikes or repeating arc patterns. With the ambient RF noise established, go to the Record tab, set capture mode to manual capture, fill in the record info, press record, and save the waveform. With this ambient recording, you can now compare it when turning on loads and breakers. If you're still seeing spikes and/or repeating arc patterns, continue turning off breakers and loads until the waveform flattens. If all the breakers and loads are off, but you are still seeing high RF noise, you may have the issue upstream from the load center, such as a transformer. Step 4. Set the IntelliArc in trip capture mode by double-tapping the blue button on the side of the IntelliArc and verifying the power LED is blinking. Putting the IntelliArc in trip capture mode will help you capture the high RF arc noise and can determine if you're seeing a real arc fault or a load causing an unwanted trip. Step 5. Turn on the loads on the circuit to find the source of the RF arc noise. Start turning on one load at a time and observe the RF noise on the Live Data tab to see if the waveform changes into a spiking or repeating pattern, like the examples below the Live Data graph. If you do not see any changes to the waveform's shape, turn on the other breakers and the loads connected to them to see if a load on another circuit is affecting the tripped breaker. This effect is called crosstalk when the RF arc noise in Circuit 1, the driven line, overlaps and affects Circuit 2, the victim line, when both lines are laid close together. Removing the load causing the high RF arc noise in Circuit 1 will also remove the high RF arc noise in Circuit 2. When high RF arc noise is present when turning on breakers and loads, note the make and model number causing the change. Step 6. Record the high RF arc noise caused by a load. Record the waveform by going to the Record tab, select Manual Capture, fill in the record info, press record, check the RF waveform, and then save the file. You can use this data to report or show the load is causing the circuit to trip. If you find a real arc fault, despite changing to different loads, you may have a punctured or broken wire in the circuit that will need to be fixed or replaced. Continue repeating Step 5 and 6 until all loads and breakers are turned on. Step 7. Remove the non-compliant load from the circuit or replace them with a different load, preferably an FCC-compliant version. FCC-approved products means that the device does not emit harmful radio waves that can affect other electronics, including breakers. Loads that cause high RF arc noise or crosstalk are not likely to be FCC-approved devices. This can be as simple as replacing LEDs or charging devices. If you have a larger load, such as a dryer or a microwave, you will have to reach out to the appliance manufacturer for a solution. You can also try using plug-in RF filters to reduce the amount of RF noise being emitted by the load. You can compare before and after using the Live Data or Record tab. In the next video, we'll go over on how to troubleshoot ground faults.